Hey, fifth grade. Welcome to your circuits lecture. Today is Tuesday. Yes. Sorry, again, I record this stuff ahead of time, so I have no clue what day it is for you, really. I don't even think I know what day it is for me. Anyway, so go ahead and get the slides pulled up so you can follow along and start thinking about your warm-up. You should know what your warm-up is. It says, what is a circuit? So pause the video if you don't know and go figure it out. It's one of your vocab words. So a circuit is a complete path through which a current can flow, an electrical current can flow, okay? So our lecture today is about different types of circuits. It's chapter 8, pages 94 to 95. So if you move to the third slide, you'll see that the amount of current, the electricity flowing through a circuit, can be affected by multiple things. Those three things being voltage, resistance, and materials. The materials that the circuit itself is made of. Okay? So the first one we'll talk about is voltage. And using different amounts of voltage can affect how much current there is. So higher voltage, more current, lower voltage, less current. You've probably heard of voltage in terms of batteries before, like a 9-volt battery. The bigger the number, the more voltage. All those AA, AAAs, all those, they have different amount of voltage as well. Okay? So, that's simple logic. Higher voltage, more current, lower voltage, less current. Resistance is the next thing. You've probably heard the word resist before. Resist means like not wanting to do something. Like you guys resist doing your homework all the time. You don't want to do your homework. Or you have to resist having that one last piece of candy because you know it's not good for you. So in terms of an electrical current, resistance is defined as the measure of how difficult it is for an electric current to flow. So the more resistance there is, the current decreases. And the less resistance, the current increases. Think about if you have to run a race and you're on one road and there's nothing on that path or that road. All you gotta do is run from one spot to the other. But next to you, your best friend's on the same length of road, but there's like a bunch of walls that they'll have to climb over. That's resistance, okay? It makes it harder for the current to pass through. The last thing that affects current is material. There's two ways to think about material in current. Material as in what the current itself is made of. So some materials resist electric current more than others. A conductor, you've heard of these before, conductors offer the least amount of resistance. They allow the current to flow the best. So a good conductor, the greater the current. Conductors are often things like metal. In other terms of material, the thickness of a circuit can affect how much current can flow through. So if I take a really skinny wire and make a circuit, and a thicker wire and make a circuit, the thinner wire, it's going to be harder for the circuit to flow through. There's going to be more resistance. The thicker wire, there's less resistance because it can move more freely. Think about a regular garden hose versus a fire hose. The garden hose is only about that big around, and water can only flow through it so much at a time. But that giant fire truck water hose can get so much more water through it because it's thicker. It has a bigger circumference, okay? So, those are three things that affect current in your circuits. Now we're going to move into circuit types. We're going to learn about two types today. The first one is a series circuit. Series circuit is really simple. It's a circuit in which there is a single path. It's a loop, just like a little circle. And so if you disrupt the circuit, it'll cut off. It'll stop. It won't flow anymore. The more things you add, the more the resistance. So if I have a circuit that's made up of battery, some wires, and a light bulb, there's not much resistance. But if I add in another light bulb, there's going to be more resistance. And if I take either one of those things out, it's not going to work. Okay? Here is an example of a series circuit. Okay? So you have your battery here, that's your power source. Wires are connecting to these two light bulbs. And you see my orange line, the power is flowing through this all in one loop. And if I take out this light bulb, it's going to separate these two wires and it can't flow anymore. Or if I break this wire, it won't be able to flow anymore because it's in one continuous circle. Okay? The next type of circuit is called a parallel circuit, just like parallel lines you learn about in math. So a parallel circuit is a circuit with more than one path for the electrical current. You can connect multiple things, like put two light bulbs in the parallel circuit, and removing one or one going out will not affect the other. The current just flows through the other path if you do remove something. So I'm going to show you the picture of it. So over here we have our battery, just like normal. It's supplying energy to these light bulbs. First you have your one little circuit here, one part of the circuit, and he's getting his energy. Light bulb A gets its energy from the battery right here. Light bulb B, it has to travel through the whole circuit. But let's say I take out A, or A burns out. It's still going to be able to get to the parallel circuit. To light bulb A because light bulb B because of the parallel circuit, okay? So parallel circuit, it doesn't matter if you remove something, unless you remove the energy source and it won't work. But you can remove one of the things that's part of it and it will still work. There's a picture of them on slide 10. It says circuit types, and the picture there is the same thing I drew. It's just in a diagram form instead of the pictures. So that little double line is the battery. These also have a switch, like an on and off switch. Just ignore that for now. Imagine that it's just an unbroken line between the bulbs. So the parallel circuit's on the left, and if I take that top light bulb on the parallel circuit out, the bottom light bulb will still light up, and the other way around, okay? The series circuit, I see those two light bulbs, those two little X's. If I take one, it's going to break the whole chain. So the difference between series and parallel is that parallel doesn't matter if you remove something. Series, if you break the circuit, it will not, the current will not flow. A practical example of this is Christmas lights. So you guys are probably young enough that most of the Christmas lights you've put on your trees before or outside are all working on series circuits. Not series circuits, on parallel circuits. But they used to work on series circuits, so it was really, really annoying. I remember helping my dad with this when I was a kid. We'd go to put the Christmas lights on, but we have to test them, and you plug them in and they don't work because there's one bulb that is out. And because it's a series circuit, when one stops working, when one doesn't take the current, the rest of them can't. So you'd have to go through every single bulb and figure out which one it was and replace that and hope there wasn't any other burnout bulb. But nowadays, all of the Christmas lights you see in the stores, they're on a parallel circuit. That's why they have more wires in them. Because if one goes out, the rest won't go out. Some of them are built on multiple series circuits where maybe a section will go out, but the whole strand won't go out. So your homework assignment's on the last slide. It is to think about something in your daily life, like maybe the lights in your living room, and guess if it is a series circuit or a parallel circuit. Think about it. If you turn on the light in the living room or turn it off, does it turn off the TV? That's your hint. Have a good day.